Hello, my name is Narisa Chu. I've been on Board of Governors for Consumer Electronics Society for the last 2 terms. It was an honor for me to represent CE Society to one of the newer initiatives within IEEE, the BRAIN initiative. And it was through this role I started to meet Dr. Paul Sajda, who is leading the IEEE BRAIN initiative. For myself, since 2011, I have poked my head and stick my fingers in this mysterious area of brain technology. And when I met Paul, I know there's much higher quality and much more in-depth research and development that really opened up my eyes. Through this, I have been able to introduce 3 speakers along brain technology, those who are thinking out of the box, those who are working across different disciplines. And today, Paul offered one of the most excellent speech at the ICCE. And I am very glad that we have this opportunity to perhaps discuss with you your personal view as well as the career perspective. So let me ask you the first question.
Sure.
When did you start to get interested in this brain technology and why?
Right. So it was probably when I was an undergraduate at MIT. I was always interested at the interface of biology and engineering. I knew that there were a lot of potential applications there. Then I worked, did my thesis at the Artificial Intelligence Lab at MIT and realized that what robots could do in robotics was far beyond, was not anywhere near what the brain could do. So it kind of got me thinking about that, and the reason I went and did bioengineering at the University of Pennsylvania was because it established the first neuroengineering program in the United States.
As we both are wearing hats, saying Happy New Year to everybody who's viewing this, I also would like to pass a crystal ball to you. And what do you see in 5 years? Something outstanding in the neurotechnology, and what do you see in 20 years? Just play a little
game. So in the consumer space in 5 years, I think for sure there will be some element of neurotech in all of our lives. So this could be neurotech that is sensing, it could be neurotech that's stimulating, but kind of to help us improve our quality of life, everything from the quality of sleep to our stress levels, things like that. So that I see in 5 years. In 20 years, it's so hard to know, but I imagine that neural feedback and also just physiological signals will be critical for helping learn how to personalize our experience, from how we operate in our cars to how we operate in our homes to even how we learn. And I have to say it's really exciting, but it's also a little bit scary in the sense that we always have to worry about, once we change the way we interact with not just computers, but how that interaction changes how we interact with each other. We just have to try to figure out how to make sure that that has benefit to all of us and doesn't cause problems in the long term.
So what do you think, how important the brain technology is in general, in engineering, as well as for consumers?
So it's really interesting because there's been, I think, dramatic increase in the amount of work that's being done in the brain area. So a lot of that is in the biology area and things related to new types of imaging methods for seeing what's happening in the brain of a mouse or a fruit fly. That doesn't necessarily translate to the consumer area. But at the same time, there's been a lot of work at the engineering side, understanding the interface between humans and machines. And that, I think, has much more application to the side of consumer electronics. And we're starting to see some applications being put out there from that those applications, we're getting some feedback about what still needs to be done before this is going to be a usable technology. Just like any kind of high-tech thing, you typically get very excited about it, you put it out in the marketplace, you get some important feedback, maybe there's a dip in the excitement a little bit, but then you use that feedback to make the next iteration.
Well, Paul, your resume looks really impressive. You're director and co-director of high caliber research centers in Columbia. You're leading the students to start up companies based on the neurotechnology. So what motivates you to, in addition to all your teaching load and research load, to actually lead the IEEE Brain Initiative?
Well, so I've been an IEEE member since I was a student, right? And so it's been my professional organization, something I felt, important to be a part of. And just like any kind of volunteer work, you volunteer your time, I volunteer your time. I thought it was, an important thing for IEEE to be involved in. I mean, quite honestly, without, support from you and the other volunteers, we wouldn't get anything done. But I think there are enough people that are excited by it that it's actually easy to spend the time doing that. I think it's one of the fun things I like to do.
Well, thank you very much for complimenting me. So another sort of policy issue, could you elaborate on U.S. investment in the brain technology and how we can put ourselves more competitive in the global perspective?
So the U.S. Brain Initiative, which was launched by the White House a few years ago, is quite large. I mean, in fact, it's the largest brain initiative in the world. It's well over $1 billion. The projection is about $4 billion, and it has a major focus on technology, development of new methods to sense, interface with the brain being, whether it's animal models, but ultimately they want to affect human quality of life. And so that's because there's a technology focus, and there's also a technology focus of the big European brain project. It was obvious that IEEE should play a big role. I think what we can do, though, is also start to play a role in understanding how we're going to translate some of this work, not just into the medical side. NIH, FDA, they have that, but like here, the consumer side, because we all know that if you can get products into the consumer space, there's huge benefits to society. There's reduction of costs, the economies of scale, there's huge amount of improvement in the technology that can be used across multiple domains. So I think the thing that we're working on in the IEEE Brain Initiative is to kind of push some of that investment by funding agencies and the government and obviously corporations to invest in translation into the consumer space.
Wonderful. So may I ask you, what do you see in the future as the most important breakthrough in the neurotechnology?
Right, so from the consumer electronics side, it's really going to be figuring out how to take the types of signals that we can measure in a nice usable environment and provide value to the consumer. And some of this might be not something that occurs immediately. So if we think about, some of these new types of machine learning systems that require lots of examples to figure out whether or not you're interested in this particular thing or to personalize your experience, it could be that kind of space. So the notion that we've now created platforms that can really seamlessly and in a usable way record these signals over long periods of time, and using those as inputs to machine learning, after enough examples we're going to see added value, just like we do now with how Google Translate, after looking at enough textual pieces, now can translate across different languages better than really almost as good as a human. So it's going to take some time, but the main thing is get that hardware out there, get that sensing out there, and give us some time to collect that data.
Last question, sure. Also light-hearted question. We talk about this on the side. There's the neurotechnology, there's the fog computing, and cloud computing, and we joked about dual computing. So What do you think would be another rock star technology that competes with neurotechnology, or perhaps complementary to neurotechnology?
Well, so there's a lot that's going to go on and be involved in genetics, right? So, I obviously have a lot of work in the biology area and the neuro and bio field, but it's really interesting. Our ability to program our bodies genetically is also something that, you want to talk 100 years from now, maybe there's a way to program in our bodies some type of program that allows VR to be put into our eyes, So I think that the thing with this kind of stuff, and we had talked about this beforehand, is to see what's going to happen in 20 years. Look at today's science fiction movies, and it's probably true that 90% of that's going to come true.
It's really exciting. It's
for
also
better or
scary.
worse. Yes, for better or worse.
Well, thank you so much.
Thank you,
Your talk
Narisa.
is so inspirational, and your research is highly regarded. We are really privileged to have you here.
Thank you. Thanks very much.
Thank you.
Panasonic.